to quickly just start with today's workshop. So welcome everyone. Thank you so much for workshop 8. This is our third month actually, which is so exciting. And today will be all about intro to spatial data. So we are going to kick things off by, again, like catching up with Sarah's presentation. Then if anyone has any questions about the communications assignment, let's get those out of the way. Then I will give a bit of a talk about spatial data, coordinate reference systems, vector data, raster data. Then there will be a lot of demos and exercises. We're going to go through a lot of stuff. And because there's going to be a lot of stuff, I have created a skeleton script for you guys. So it will be in the scripts folder. Everyone will be loading that one in, and I have made gaps in it. So you guys will have to figure out a few things. Otherwise, we'll keep going through it and run that script. We'll go through loading in shape files, reprojecting them, merging them with CSVs, aggregating things, visualizing things, raster data. We'll go into Malaria Atlas R package as well and pull everything kind of together. And there's a little bit of data wrangling that I think we haven't really covered, but would be useful. So if we have time, I will go into a few more things. But with that one, I will stop sharing. And this is Sarah's time to shine. So you have your presentation ready, I hope. And what we will do, if you start sharing your screen, Sarah, at the bottom, there should be a share button, green. I will count down from 3 to 1, and then I will put the timer on that you have 3 minutes. So exciting. We can see your RStudio.
Okay.
Fantastic.
Hello everyone. My name is Sarah. I'm a data analyst, and I'm here at MAP as a volunteer, and I'll show up some things which I've been doing here at MAP. One of it is data extraction, as you can see from here. I did the malaria epidemics in Africa data extraction. And how did I do that? I took the data from the source from internet and extracting them to the Excel. What were they for? They were used by the senior modelers for literature review for further doing. And the other thing which I did, I was given the data which are the risk factors of VHF and also the malaria data. What I did was doing the data manipulation, showing the visuals and everything. And it was for learning purpose. As you can see, this is me, the kid at MAP. Yeah, learning, getting to know more about R and the part of doing the visuals and so and so. That's all. Oh, thank you. Thank you.
Thank you so much. You did it in less than 1.5 minutes, so that was beautiful. Thank you so much. And it was fantastic with the little baby, but come on, you're growing up. So thank you so much. I know that it's quite hard with the timing and no text and everything, but using the cursor, I think we were talking about this during the last workshop as well, that guiding people through as you're giving the presentation, that's really, really useful. And I hope, Sarah, you have been able to watch the workshop recording, and hopefully you will be able to use those skills for future presentations as well. So thank you so much. That was such a nice way to start. I will start sharing. my screen. This one. So to start things off, does anyone have any questions about the writing and presentation assignments at the moment? Did you guys go through the materials and such?
Yes, one thing came up regarding the articles. Is it an option to use two different papers for the writing assignment as well as the presenting assignment, or can you pick? Do you have to pick the same article?
Yes. So I think I mentioned this in the Google Doc that ideally I would really like to pick another paper, just so you can show that you're happy to cover another paper. Is that okay, or would it be useful to cover the same paper, just giving like writing up and presenting about it? Or are you happy with picking different papers for the different assignments?
I'm talking about myself. I think for the same paper, for me, it works better because it takes a lot of time to understand the new paper.
Okay.
So, I would like to go for the same paper I use for the summary, and it is the same paper I would like to present.
Okay. What kind of paper are you picking? Is it a very complicated one?
Yeah, it's not easy. It's about modeling.
Yeah. Well, I'm just gonna say that if you feel like, oh, it would be a really, really long task to pick two different papers, then I'm going to be very kind and allow it. But I would just say that whoever likes a challenge, please pick two other papers. I know that we said that they're due by like the 1st of April. So to speed things up, if you would like, then yes, you can pick the same articles. Is everyone quite happy to pick an article? Have you guys been able to find one, or does anyone need like suggestions or anything?
Simplifying articles.
Okay, well, on the WhatsApp as well, if someone is really struggling or something, just drop a message that, hey, has anyone read something cool? And we can share things over there as well. Fantastic. Any other questions? How to upload things, where to upload them once you have completed the assignments? Is that all clear on Google Drive? Okay, that's fantastic. Then after this, we're going to start hopefully everyone has set everything up before this workshop. If not, make sure that you do it right now. So I'm putting it in the chat as well. There's a Google Drive folder for today's workshop. Please download everything. There's going to be a folder called data. Within data, we're going to have vector data, case data, or like CSVs and rasters. So in order for everyone to be able to follow along the script as well, it's very important that you download everything and you keep it in the same format. And hopefully everyone has set up their GitHub repo. So I will be also making suggestions that this is now when you would like to commit your changes and such. But any questions, please let us know. So how are we going to do today? It's going to be a little bit different. So with Gloria's workshops, you know, it was completely up to you guys that you open up a script and you start coding, and Gloria is showing things and Janice is helping and everything. Well, today, because we are covering quite a lot, and it's going to be the codes and everything is getting quite tricky, you're getting the skeleton of a script. So everyone will be looking at the same stuff, but there will be holes in there. So what you will see is that I've put a hashtag into some areas what you will need to fill out. So if you run it like this, it's not going to work. And as a reminder, after the hashtag, you know, everything is ignored. So hopefully this will be quite easy to follow, and we will make sure that everyone is aware what functions and what object names you need to put there. So as we are going along with the script, everyone will have the same objects and names, object names in your environment. Again, it's quite a long script. We'll see how much we can go through, but hopefully this will be a fun way of kind of just looking at it and like, what do I need to fill out? Okay, I know this is the function we need for this. Oh, what is needed here? So it's kind of like a bit of a puzzle. So any questions at any time, just please feel free to ask. If I'm fast, because I sometimes can speak fast, just give me a shout that Juniper, slow down, and I will be sharing my screen. So let's kick things off. What is spatial data? Well, we would say that spatial data is anything that identifies a geographic location. So anything that can be mapped. So for example, if we have that data that like we have a CSV, we have year, we have a disease, confirmed cases, this one doesn't have any geographical information. If we have now actual longitude and latitude, so we have coordinates, that's the spatial information. There is a gray area, what we have, that maybe it's health facility name or hospital names, and those are kind of giving you a bit of an idea, but later on you need to be able to identify the location itself. So before the actual survey, I asked how much, how everyone is familiar with spatial data. You can see that only 2 people filled out the survey. So please keep filling it out. It's in the chat. And you can see that not familiar, I'm very familiar. And just as a question I asked, like if you remember the routing data, does that have any spatial information? And this was fantastic because someone mentioned that if we combine it with the Fakeland Health Facility GPS file, then we have the spatial information. And yes, it could be added. So this is fantastic as well that you have explored the other information. And this is something that within MAP, for example, we do all the time. We get one data, that's case data or some kind of other data, and then we have another CSV that has the actual coordinates. Or we have an actual app or workflow where we can identify different locations. But this is very, very tricky. But to begin with spatial data, I know that the coordinates, when you have those 2 numbers, it sounds very simple that, oh, that's what coordinates are. But then you start working with spatial data and you realize that it is quite hard because yes, we have a really cool coordinate system around the world, how we identify one location on this planet. But the problem is that the planet isn't perfect. It's not, it's an ellipsoid. So there are different ways of actually like working with different geographical locations. This makes things quite tricky, and I have done I have traveled in lots of places and they tell me that this is the location and it's not correct. Then you figure out that, oh, they were using a local reference system, and that's how you can actually find the location. So these are things to become familiar with, that the datum, this is a mathematical model of the Earth shape. This VGS84, that's something that's the most common one. We have projections, that this is how you project the actual formula, like the datum, onto the map's surface. So we will be doing this, that we'll have coordinates that we need to actually reproject in different coordinate reference systems later on. And then in units, we can have degrees or even meters. So this is something that, like, I don't know if you guys have come across this, or this is something that maybe hasn't come across. Like, if you go into Google Maps and everything, you don't need to reproject things, but you might have got coordinates from someone else, you put it there and it's a little bit misaligned. And that misalignment could be because it's coming from a different coordinate reference system, so CRS. So this is going to be quite important when we are working with any kind of shapefile and rasters that we will get to in a minute. Because of misalignments and measurements, it's going to be something that we keep wanting to check. When you get any kind of spatial data, you want to know what kind of CRS it is in. And when you open it up and you start working with it and you notice that something doesn't look right, it could be because it's in another CRS, a different reference system. This will make sense in a little bit. I thought that this is where I would start, because actually a lot of these errors that we come across when working with shapefiles is coming from this. And this is something to, these are some of the CRS that, and like datum that you need to get, be familiar with, that VGS, WGS 84, like UTM. So UTM is when things are measured in meter. And like, for example, in England, they have a British National Grid, which is a completely different projection as well, that is specific for the country. So these are just things to be familiar with. In R itself, reprojection is super easy. So it's going to be that when you check your projection system, you use the function st_CRS. It will print out what coordinate reference system you have. And then you can transform it by st transform, and you define the CRS. So over here, you can see that this is the 4326 one. This is kind of quite normal. And this is the UTM. So you can see that the reference system is a little bit tilted. So it's a little bit different. This can be sometimes dramatic, sometimes it isn't. Has anyone come across this? Has anyone done reprojections before, or is this quite new? Anyone online?
Yeah.
No.
Yeah. Harriet and Kokoda, you guys have done it?
Yeah.
Yeah, well, you guys have experts in the room. So during the workshop as well, please feel free to ask them, and we will look at it. I thought it's, again, it might sound a little bit strange, but it's something that's very, very easy to like jump in between. It's just one line of code that you can work with a different projection later on. So when we talk about spatial data, the two main categories we have is vector data and raster data. We are going to go through these now, starting with vector data. So in vector data, the main categories we would have are points, lines, and polygons. And then you can have like objects that have all of these characteristics. But basically, these have geometry, so like a shape and a position, like X and Y for a point, and attributes. So, for example, you could have that this is one observation for, like malaria test, And then we would have total tested and confirmed cases in one location. So the total test or confirmed cases are called attributes. Within these, so again, point, this is a single location. A line is actually a set of ordered points connected by a straight line segment. There is something with lines, if you're working with, they can get a little bit complicated, but usually it's this bit that ordered points. With polygons, these are bits of area that are enclosed by a line. So I'm pretty sure that, like, if you have seen maps and everything, you would have come across this, but just so you know how these different types of data are. And again, this is vector data. Vector data is like the lines and polygons. These have like geometry. Points can be a data frame, but then we make it into a geometry later on. And these are called then, this is what we will be going through. So for example, we could have a shapefile that only have polygons. Because this shapefile is composed of multiple polygons, it's called a multi-polygon object. Then you have a CSV where you have something that connects the shapefile with the CSV. So like here, it would be the country names. So it would be name_0. We can merge these by using left join, what we have done already in data wrangling. And then you're actually filling up the shapefile, this polygon, with the data from the CSV. This is very, very exciting. And it's relatively easy again if things are matching and aligned nicely. So this is again something that we will be doing. Then moving on to raster data. So raster is very, very different. So this is when you basically have pixels. It can be different resolution, but basically it's composed of rows and columns of pixels. And then the size of the pixel determines the resolution. Each pixel represents a region, and within that pixel, there's a value. So it's kind of like, it could be 1, 2, 2, 3, 1, 2, 2, 3. It's just a lot of numbers. So with satellites, for example, they're dealing with, raster data. For example, if this would be elevation or something, again, this is just a big, big data frame that is composed of lots and lots of numbers. But then you just visualize it as one map. So that's what's behind these things. It's just lots and lots of numbers. And this is what we will be using. So again, this is continuous data, what we have. And population, elevation, rainfall, and such will be raster data. And today's workshop, we will be using monthly rainfall data that's in your folders. Before we kick things off, I wanted to mention that a lot of our packages have changed lately. So when you are doing any tutorials, maybe from different websites, you might be getting lots of errors. It might become really troublesome. We tried to get some stuff to work on Nipuna's computer, and it just wouldn't, because like a lot has changed. So I just wanted to give a shout out that when it comes to SP, RGDAL, RGOS, and map tools, you might get some errors and dependencies. It's because these R packages have been retired, so they have been archived. You can still access them, but no one is maintaining them. No one is looking after that GitHub repo where they live. So the new main packages are SF and Terra. And I really just wanted to give a shout out, because even ChatGPT, if you work with it, and rely on it, it might give you answers in different packages, and you might go on a wild goose chase when you're trying to get it to work and it won't work. And that's because you need to make sure that you're using the latest packages. So again, SF and Terra. Terra is very, very important. That's what we will use for the raster data and such. So to look at it, what you have in your folders. So when we talk about shapefiles, so this is your vector data, you might spot that in your shapefiles folder, you have something called like fakelan_HDs. And then you have 4 actual files with different extensions, and then another one with 4 different extensions. So actually shapefiles are composed of 4 different files, because each of these different files contains different information in order to plot something. So if, for example, I wanted to send a shapefile to Harriet, for example, to map, and I only send this one, she would try to load it into R, but it would give an error message. So when you're downloading or uploading any kind of shapefile, look out that you need actually 4 different files. So you have the .shv, so that's the actual shapefile. That's what we read into R. And automatically that package is going to read in all of this. So we only need to read in this. But in .shx, you actually have more information. This is very quick. It's shape index file. Then you have an attribute data file as well. And then you have a projection file. So that has the CRS. This is just how it looks like. Again, when you're working together with other people as well, just make sure that you have these 4 files and not just the shapefile in that folder. So how it's going to come up? So we're going to start doing things in R, but I thought it would be a nice introduction just to what to expect. When we load in a shapefile, we are still going to use ggplot. But in ggplot, from Gloria's workshop, you remember that we're layering things up. So when it's going to come to spatial data, like a shapefile and ggplot, we're actually going to load in ggplot to package and library SF. So that's the spatial data. Let's say that we have something, a shapefile called my shapefile. We're going to say in ggplot that this is my data. And then we're going to use the function geom_sf. So this function is going to be automatically telling it to ggplot that this is a spatial object, and it will understand what coordinate reference system and geometries that object has. So again, this is just a nice function. You're telling ggplot, hey, this is a spatial data, and it knows what to do. Within that one, then if you remember, we had this aesthetic function, and then we can fill it up with like some attribute, like total cases over here. And then we're telling ggplot that this is the shapefile, and we're going to be using like the total cases for plotting. And I don't know if we used Viridis before. Viridis is a really, really nice R package, Viridis and Viridis Lite, that you might have to also install actually. It's a colorblind friendly group of colors. So you can see it's called like Viridis, Magma, Plasma, Inferno, You can select from these. And you can use the function scale fill Viridis, C or D, continuous or discrete data. You can either leave it normal and then it will plot with Viridis, or you can actually say option or just basically type Magma with parentheses. or quotation marks, sorry, and it will know. And we can say theme minimal. And that's how we're building a ggplot from a shapefile. So again, before we are jumping on to, this is a little bit of recap, and I'm going to keep doing this, that before we go into the R script, just to know what we will be using. To read in a shapefile, we're using the package SF, and we're going to be using the st_read function. And you just literally just put the path to your file. So it's going to be like read_csv, but we're using st_read. And naturally, you want to save that object within your environment. So you want to actually also assign it to an object. When we are going to be checking out the shapefile, again, package SF, we can use names for the column names. You can use st_crs. That's going to be looking at the coordinate reference system. And you can use the base plot function. And again, it will know how to plot it. It knows what kind of object it is. Then for transformation, we are using st_transform, and we're going to be telling the CRS, like you can either say CRS equals something, or you just put in the code for the reference system. And we will also do the ggplot2 with the geom_sf. So if you are ready, steady, open up the skeleton R script on your computers. And what we will do is read in the shapefile. We're going to inspect its structure. We're going to transform it to 4326. So this is the WGS. We're going to transform it to UTM, which is the code EPSG32736. This is all in your script, so you don't have to remember. And then we will plot things. So I will. Is everyone ready?
Yeah.
Hi, Juniper.
Yes.
Yeah, so sorry, just want to ask one of the basic questions. I don't know if I missed it, but just want to kind of just get the like in terms of when you talk of spatial data, like in which context are we anticipated to use it? When do we expect to come across it? Just that so that I can attach to what we are doing.
Sure thing. No, thank you for the question. So, Paul, for you,
when do we use it? Something, yes.
Yes. So, Paul, for you, you probably have some clinical data, right? That you might have been collecting, or you're working with other health facilities, and you might have a CSV where you have, different dates, how many patients you have seen, what was the disease. I remember from your excellent presentation that you're looking at like how it progressed to like, severe malaria, like what was the outcome and such. If you have like information from different health facilities, different hospitals, then you would have longitude and latitude coordinates for your health facility probably. And then you can actually visualize it. And later in this workshop, actually, I'm going to be showing how plotting things is actually helpful with understanding your own data, and how it can actually be like a big alarm clock as well, that like something is incorrect. And in terms of other things, so if you want to visualize that, like, oh, I had a patient from a different region, the temperature data is usually like coming from a raster data from like this one. Most of the global databases are coming from satellite data. So you're getting a raster data for rainfall, elevation and such. So you want to actually maybe plot like, okay, so this patient has come from this region. What is the rainfall? What is the elevation? What kind of mosquitoes are there? So like we want to visualize the information to get a bigger overview. I hope that's useful. Can you think of how you can use it with your data? What you're working with?
Yes.
Fantastic. So if we kick things off, hopefully everyone has set up a GitHub repo or like at least an R project. I named it ECR Workshop 8. I've saved everything in here. So we have data and we are going to be using this V8 skeleton script full. Don't mind that I have other things as well here. Within data, you have CSVs here. Within rasters, you have these TIFF objects that we will come back to, and you have these shapefiles and region of shapefiles as well. When you open up the
Hi, Jennifer.
Yes, hi, Nama. How are you?
Hey, I'm good. How are you?
Good.
Yes, I'm only able to access the data in the recommended regions file. I'm not seeing the scripts in the Google shared file, and I don't know if it's just me or there's something that I might be missing.
Could you check the link again? I will put it in the chat. But this is how it looks like for me.
Okay, yeah, I had to refresh it again. Yeah, I'm able to see the script.
Fantastic. So within scripts, we have the skeleton script. Does everyone have this open already?
Jennifer, you want us to use your scripts? I thought you had said first we download them down or we use your script.
Yes. Winde, thank you for joining. I know you were a little bit late at the beginning. So basically what you have, you need to download that whole Google Drive folder with everything in it. So you have the data, the scripts folders. You want to open up an R project or a GitHub repo. If you don't have time for the GitHub repo, we can do that later. And within the script, you're going to get the skeleton of a script. So it's going to be that everyone can follow along, but you actually have to fill out some of these holes. So this will be today's workshop. I thought that this would help, that you are getting used to using someone else's script, and people will be able to notice what we need to change. So with the hashtags, you can see that those are supposed to be like functions or objects that you will have to enter throughout the workshop. Does that help? Are you happy to download everything and start up your script? Hopefully you are. So I've cleared my environment and we're going to start running things. So hopefully everyone has installed all the packages that were needed. Again, we have SF, that's for shapefile. We have tidyverse for all the data wrangling stuff. This will be later for the date stuff. Terra is for raster data. TMap, this will be really fancy interactive mapping. GG Spatial is basically for ggplot extended for handling shape data. GG Animate, we're going to create a GIF. This is something I will just demo. So in this script, you'll see that there will be quite a lot of things that I'm just going to show you. So you know that how it could be done, and it will be for you to later explore if this is something you want to use. So the beginning of the script starts with getting the working directory. Hopefully, if you have set up the R project or Git correctly, then it's going straight to today's workshop folder. And I've created a bit of a script where today we're actually going to create automatically a folder from RStudio into our working directory. The first line here says that we are getting the system date, and we are going to use this format, the day, month, year. We are going to assign it to today object. So you can see that it has saved today's date. We're going to specify a file path where we're going to paste outputs underscore today. So outputs underscore today's date. And the function director dir create, basically, we're going to say that this is the path. Don't show warnings, but recursive, it's kind of like send us a message if it has been created. For today, it's not telling me that it has been created because I've already made it up, but you should see that it will show up over here. I can delete it actually. So this is how it will look like for you. You run this code and it has popped up. We have created a folder. Is everyone happy so far? Do we have our outputs folder? And what you should be also noticing that you cannot see it, but I'm using Control Enter at the end of the line or beginning of the line to run a line. So if you don't see that I'm clicking on run, it's because I'm using the shortcut on my keyboard. All good? Okay, so the first section, exercise 1, is that we are going to be reading in and inspecting a shapefile. We have this fake land, and we want to read it in. It is within our data, shapefiles, and this is the shapefile we want to read in. So over here, how do we need to fill this out to read this in? Anyone jump on?
SC read.
I couldn't hear.
Is it SC read?
Yes, SC read. I will try to have this up. Yeah. So we can see. So this is the path. So I'm going to do this on my screen. ST read. It pops up. In the quotation marks, you just paste in data shapefiles backland.shape. If you run that code, we have read it in. Yay! Is everyone happy with this? Once we have read it in, you can see that we can open up the data frame. And we have country ID, country, I think district code, admin 2, admin 1, and geometry. Feel free to put on your videos so I can just see that I can get thumbs up when we can move on to things. That would be really good. Kianema. Powell, Wendy, are you guys happy with this? Kokoda, yay! I know you know. Powell, have you been able to complete this on Wednesday?
It's the one I'm trying to do right now. Let me just inform you when I manage.
Okay, all good. So basically, we just want to use here the function stread, and you can copy the path to the shapefile from here.
So
And what you
it's all those in the shape files, or which one specific in the shape files? Because I can see a lot.
Yeah, so we only want to read in one data file, which is called fak_hdx.shape.
Okay.
And as a reminder, the folder itself has all those other files. We don't need to read those in. The actual function stread automatically knows to look for all these other files that have the same name but different extension. But we only need to specify the shape. Then, if people have been able to read it in, you can actually first see that it has appeared in our environment. It looks like this, that we have the different admin 1. So those are the regions, admin 2, those are the districts. And this geometry column is going to be really, really important because this is where your geometry is. If you have any kind of object that is a spatial object, then it will have a geometry column. And if you're doing any operations and such, we need to keep this. If we lose this, it's no longer a spatial file. You can also see that here, I don't think we have had this before, that there's a drop-down button next to the name, and it gives you a bit of information what the actual object looks like. The $ means the different column names, right? So country ID, country, and it gives you that these columns are numerical attributes, factors, characters, and such. To inspect it first, to have a look, we can literally just put this in, the object name, and what will come up is that this is a polygon. It has X and Y. This is the bounding box. So this is the extent of our shapefile in the coordinate system. The CRS is WGS84, which is the most common one. And these are our like attributes and the geometry. And it says, 5 fields, 46 features. For this answer could be that we are just printing out the name, or you can say print Bakeland HD, and it's the same stuff, same information that gets printed out. For the column names, what function should we write? How do we get only the column names?
Names.
Names. Perfect. We say names, we're only getting the column names. To check for the coordinate system,
STCRS.
perfect. So ST_CRS. Then you run it, and it gives you a bit more information. but it's the same that WGS 84. And a bit more information. You can see this is the datum, ellipsoid, the ID and such. Has everyone been able to figure these out? Print it out, names, STRCRS. Great, thank you, Nima. Then we're going to create a very basic R plot. You just use the function plot. And look what has come up. So as you can see, it prints out 5 shapefiles. These are our 5 columns. We had the country ID, the country name, admin 1, admin 2, and you can see that the colors have changed because this is regional data. These are the regions, and these are the different districts. And here you can see main is just the title. So the best workflow for any kind of, whenever you're working with any data is to load it in, check how it looks like, and then plot it. Is everyone happy so far?
Is everyone happy?
No. No, alikuwa zile danza.
All good. Are we happy to move on to reprojecting things?
They are still finishing with some things.
Okay. All good. I will have this up so everyone sees the answers. Wendy and Powell, how are you guys getting on? How are you guys getting on? Anyone who's online, have you been able to follow it?
You just run it for you.
I run this.
Yeah.
I'm running.
You run boys.
So you just wanted to see this one.
Yeah.
Backland or range.
Everyone has.
No.
Everyone has it?
No.
I was very, very kind and I put the answers into the chat. So anyone who has had any trouble, I have copied out the answers. If everyone is happy, we will move on to transforming the CRS. And I wanted to actually show a bit of a trick. So you can see here that my comment is running over. We can change this by going to code, and you can select soft wrap long lines, and it will automatically wrap everything. So it's quite handy if you're working with someone else's script. They might have had this on, and you don't need to scroll back and forth. Okay, so over here, we want to transform.
Excuse me, could you repeat out? Okay. So you go to the code. Okay, I get it.
Yeah, so code soft wrap long line. You can also select all the rainbows, and then it becomes very, very colorful. I don't know if this is helpful now though, because you can see that everything just changes colors. Okay, so we are going to be transforming things. What are we trying to do? We're trying to transform this shapefile that we have in our environment to WGS84, which has a code. This is kind of like the code system, 4326. So what is the function when we want to specify what CRS a shapefile should have? I'm going to be very kind again. Yes.
ST transform.
Thank you. So Charles has given the answer. ST transform. We will be using this one. So the way we would do it is ST underscore transform, and into the CRS you would type in the actual code, which is 4326. We can run that line and you can see that a new object has appeared. If we want to verify that the CRS has indeed been changed, you can see over here that we have user input and it is WGS84. Has everyone been able to fill this one out? Because this is what we will do for UTM. It's a bit more exciting for UTM because it is quite different. Over here, we will put the code. We actually don't have to specify CRS, but literally would do this. You run it, a new object has appeared. So we have the UTM to verify. We'll print it out. And you will see that that was the user input. That's the UTM code. And we have had two projections. It has gone from 84 to UTM. And you can see down just a little extra message has come up. And we have a couple more things that popped up over here, just as we did the transformation. Now that we have used st underscore transform to create these two shapefiles with different projections, then we can plot these. So just like in the presentation, we use plot, or yeah, just like before. And we'll plot the other one. And you can see it's a very gentle one here. But you can see that it has moved. Can you guys let me know that you have been able to get to this stage? Do we have all these objects in our environment? Thumbs up.
I'll need more time. I don't know why I've been failing to read the shape file. So I tried reloading those sets you had said we should have them. So I ran them and then again I start.
Would you like to
It's
share your
showing me
screen?
that. Okay, let me share.
Yeah, let's have a look what's happening.
So Juniper, we are still behind for us. We are still struggling to read.
Oh, is the reading?
Okay.
Yeah, but
Yeah,
we are
are
done.
you there, Jennifer? You've seen this one?
Yes, and I can spot right away what's wrong. You are trying to load in a CSV, but we want to read in a shapefile. So you're actually pointing.
Shapefile.
Yes. So I can see that you have created a folder called Lesson 8, and I think you have started up on our project. I think it's connected to Git, which is fantastic. In that folder, you want to put the actual Google Drive entirety, the folder. So if you'd like, I can share my screen just so we make sure that you have exactly what you need for the workshop. So what you need to do is that we have the workshop Google Drive folder, right? You can select all of this. You will download it. All of that. Then whether you set it up on GitHub desktop or somewhere else, you can find your actual folder. So I will show that for me. This is the folder. I saved it when it was just the data, and basically the data is exactly what we have here. And this is important because this is how you will be able to make sure that you are reading in exactly the right data.
Okay. Did I download the wrong data? Oh my God.
I will put in the Google Drive link again.
Shape file.
You definitely have downloaded the script, which is great, and opened it up. In the DAR office, what's happening when you guys are reading things in? What errors are you guys getting? Do you want to share your screen? You guys are muted at the moment.
Okay. You are talking slowly.
So we just want to plot before.
So they want a quick recap from the beginning, like they are, because they have been struggling with reading the file. So now they have the file ready. They need to like.
So everyone has the shapefile read in. Is that all good?
Yes. Yeah.
So everyone.
So is this the plotting that's troublesome?
From here.
I think from
1 to.
Yes. From inspect.
1.2.
Inspect the data.
Did you? So what does it look like? Does anyone want to share the screen just to show me how it looks like? We need to make sure that the data was read in correctly. I can stop sharing.
Oh wow. Una print,
Does anyone? Yeah. Sarah, share.
Let me share.
It's useful for everyone. Yeah, please feel free.
One is sharing.
Fantastic.
Yes.
Okay, so I can see that you updated how to read it in, and I think you read it in correctly.
So
the next bit.
We after reading the data.
We don't hear the beginning.
This one. Yes.
Oh,
after reading, we don't know what to do next. We were struggling to read, so we don't know the next step.
Okay. So, can you see what I'm drawing?
Yes.
Over there, what we're going to do is print vehicle.
Like you are printing.
Yeah. So
can you see?
Right print. You have to read the hashtag and then write print.
Yes. Yeah.
The second
Yes.
one is names.
The second one is name.
Yeah. If we want to check the colors of the
Okay.
and the last one is STCRS.
ST.
And that's software already.
this. And then I run.
Yeah,
You can check.
You run all of them or one by one?
One by one.
Yeah.
Okay. Control enter.
You can either highlight and run everything, or you can run it line by line. And
It's now
the
working.
there you go. It's in your console.
Can you plot?
How to then
Just run the plot.
let me run all of them first.
Fantastic. And then when you run plot, you don't need to change anything.
Yes, sir.
Yay!
Thank you.
All good.
Thank you.
Thank you. Oh, my pleasure. Does it make sense for everyone how to fill out the R script? So again, like we're trying like this, that we have these hashtags. That means that you need to fill something out. So there's hashtags before fakeland underscore HD. That means that you need to type in a function there. Over here, when we get to gplot, you will have to fill out like what is the data, what do we want to fill, what do we want to passage rub by. Is everyone happy?
Yes.
Yeah.
Fantastic. So we're moving on to transforming things. I'm sorry, I have already given the answer. Maybe I should quickly hide it. And Kokoda as well mentioned that we are going to be using the st_transform function. So at the moment, you can see on my screen the actual answers that we're going to be transforming the shape file. Well, the first one is actually not transforming it because that's what it was, but just for visualization. And we are assigning it to a new shapefile. And I have entered the projection name to the shapefile. So it's just going to be a different object in our environment. We're going to do that again. We're using the same shapefile, but we're projecting it to UTM, and we're saving it to a new object again. Once you have done the transformations, you can plot them. It's going to be very nice and gentle, the difference between the shapefiles. And after that, we're going to move on to ggplot, which is going to make it look quite nice and everything. So let me know when you guys are ready to move on to the ggplot section. Powell and Wendy, are you guys able to follow? How does it look like for you guys?
Yes, we're following. I just had a problem with the internet to upload the data that has the shape files. So once I do that, I'll quickly run and catch up.
Okay, all good. If there's any questions, just give us a shout because you need to make sure that everything is loaded so you can follow the script later on. How are you doing, Powell? Hopefully all is well. If you guys are ready with the transformation bit, then we will move on to ggplot, where you can see that I have left out a function that we need to add. So our task will be to figure out what kind of function is coming here. And I have had this in the presentation. So for correct. So over here, if you delete the hashtags and we type geom_SF, just as a reminder, first we are saying that we want to create a ggplot. We are telling ggplot that this is a shapefile. We are specifying that this is our data, and we're just adding a title here. So if you run this one, you get this polygon.
Which number? 1.3. 1.3.
Yeah.
No, you did 1.3. 1.3 ndio hiyo kuplot hizo nani. Baada ya hapo ndo unaenda tu kwenye transformation. Inakataa kwa nini? Transformation wewe unakumaliza.
Feel free to use the chat as well if anyone has any questions. All good?
Yeah. Does everyone have this map? Yes, we are good. Okay. Everyone is on the page.
Fantastic. I have to say, all good? I know that I think a few people have said in the survey that they have never created a map before. So congratulations. This is the moment that you have created a map. So exciting.
For sure.
And hopefully it looks like it's actually pretty easy, isn't it? That like we literally just read in the shapefile here and then you plot it and there you go. Hopefully it doesn't look too scary. There are just lots of comments and everything. And the next one is literally using the ggplot, but we are plotting the two different projections in separately. So you should be able to see the difference between the two plots, right?
Yeah. Juniper, can you explain maybe a bit about the differences of the two projections? I mean, other than the tiltation, if there's anything else that we need to sort of like maybe have an understanding of, and also which ones are more common?
Yes. Thank you so much, Nema, for the question. So what I'm actually using, the two examples are the most common ones, like the WGS. It's very, very simple, and this is what you would usually get when you download it. But if you want to actually calculate the distances between certain areas, you actually need to use UTM, because that's going to be calculating things per meter. So again, this is kind of just when, for example, with Usman, he is running his big spatial model and such. And for that one, he was running it in WGS. And then he was like, something isn't correct. And he had to reproject everything to UTM because he is using mathematical models. And then from UTM, when you want to share it with other people, then you would maybe like convert it back just so they can visualize it correctly. So this is very much user case. And actually later on, we will be using the UTM transformation because something doesn't work within another projection. I hope that was a good brief example.
Juniper, just go up a little bit of your script.
This is reading in, printing names, ST, CRS, ST transform. What are you looking for?
Okay, I was looking at the reading. I did upload the shape files, but in the shape files, when you open the shape file, the whole shape file, I tried to read, it couldn't. So when I opened, I found also there's national, and the other type of a shape file.
Yes, so we want to read in this one, the only shape file.
Which one?
So
The
FAK
one FAK
underscore
okay.
HD.
Okay. FAK underscore HD. Ah, okay. So FAK underscore HD. Yes, super. Thank you.
Oh, good. If for a shortcut, what I usually do is that if I click on a name, you can say rename. You select all of it, Control Copy, Control V, and you just paste it in. Especially with the rasters later on, there are going to be much, much longer names. So I really hope that everyone has been able to get to here. Exercise 2, if we are ready to move on, is actually going to be to make something very beautiful. So again, you will have the skeleton of the script, but you have to fill out what's missing. What we want to do is use the Viridis palette. You might have to install Viridis R package. We want to add polygon borders in white or black. And maybe we want to add labels to the polygons as well. So the outcome of this one will be like this. Ooh, it looks exciting, hopefully. And this will be, again, just layering things on with ggplot. So if we move on to line 109, you have this snippet with ggplot. We are saying that this is the data, this is the shapefile. geom_sf, this is a shapefile. Fill it by admin2, so by regions. If you want to add labels, you can remove this comment like this. And you need to add a plus because we're layering things on. If we want to use Viridis, discrete, we can remove the comment. So we are switching that line on. Labs, these are all titles. So again, if you remove the comments, I'm literally just deleting the hashtags. This is adding things on. We are saying theme minimum. And then here, we're saying the plot title is going to be bold, the size is going to be 16. If I remove the hashtag before legend position, that line becomes switched on. And if I run all of this, then we get this, which is very exciting. So this one actually, never the question that ST point on surface may not give correct results for longitude, latitude data. This actually goes away if you use the UTM shapefile, if I remember correctly. Yeah. Because in UTM, the projection is a bit different. So it's just kind of giving you an alert that within WGS 84, you know, the coordinate system is measured in, what is it? Like coordinates, like minutes, seconds and such. But with UTM, so if you change the object, the data name to UTM, that error message goes away. And within here, I said that, oh, we could use plasma. So scale Viridis discrete data. We could say plasma. This is plasma. Oh, option. Then it changes the color palette to plasma. So over here, if I comment this one out, so I put a hashtag there, then there are no plots because this one is getting ignored. I switched that off. Over here, the subtitle, if I click on Control-Shift-C, that's the shortcut for commenting something out. If I run it now, there's no subtitle. So these are how we keep adding more and more like details to ggplot. If I want to move the legend, then we can move it to bottom. And then it has moved to the bottom. Or it could be right. And then it has moved. So this is how you can play with things.
It's not. Say something. I don't really want example, but you can ask. Do you want to ask? Yeah.
Can I just share a little bit?
Of course, please. How are you getting on?
Thank you. Thank you. Almost there.
Good. Do you want to share your screen?
Maybe it's something else.
What's happening? Let's see. Okay, you have the shape files plotted.
Yes.
So you are at the transformation part.
Yes.
So do you remember what function we need to use?
To change, forgotten. We are changing the coordinates.
So we're not changing the coordinates. We are just changing how they are projected onto the Earth surface. So we keep the shape file the same, but we are going to change. I'm going to draw on your screen. Just here. Can you see it?
Yes.
So
yes, right there.
Yes, in that line, delete those 4 hashtags first. Great. And we are going to be using the st_transform function. Fantastic. And then for CRS, it is in the comment above that we need to put 4, 3, 2, 6.
In the comment box, I confirm 4326.
Yes, correct. If you run that line, yeah, you can see that a new object has appeared in your environment on the top right corner.
Yes, yes, yes.
Yeah. So that's
Yes.
the now
So just a minute.
Yeah.
What does 4326 mean?
So that means that the projection, the coordinate reference system, the CRS, is this WGS84. Again, I think you missed the beginning of the workshop, so I was just introducing how these different coordinate systems are kind of like a different way of identifying locations on the Earth's surface. So it's kind of like a mathematical model. And when you're using different shapefiles and you're working with other people, they might have these different coordinate reference systems that can create a lot of problems later on. So you have run that line, you have done the transformation. The next line is that st_CRS. If you run that one, we're just going to verify, and it prints out that the actual CRS, so coordinate reference system, is indeed the 4326. If you move on to the next session, we're going to be then projecting it. So we're going to use again st_transform, but we're going to change it to UTM, which is a different reference system, where the code is that 32736.
Right, 32. So right here.
One line above.
Above, here.
So you want to get rid of those hashtags.
32.
So not over there. We need a function. What was the function we used above?
The function said we used UTM.
No, we're using a function for transforming things.
The function st-transform.
Yes, correct. That's a function.
Yes, st-transform.
All right. Fantastic. Now you have those hashtags.
Then use the number.
Yeah.
The number.
The number is in the line above, so you should be able to see that it's 32736.
We are still using the 4326.
No.
32736.
Correct.
32.
That's a bit slow.
That's 32736.
Correct. If you run that line.
Okay. I've run it.
Yeah. We're going to check the CRS. So if you run that one, it will print out.
I check also. Okay. Yes. It's printed out. And I go to the plot.
Yes. Then you can start plotting things. Sorry.
You can go to the plot.
and just run things. Fantastic. In the meantime, in the office, how are people getting on with ggplot? Have you been able to recreate a beautiful plot with labels and titles?
Yeah.
Fantastic. Has anyone come up with something very special? Have you changed something completely?
It is not special. They want the messages. You say it. They got someone got the warning message.
Is it special?
It is something weird. So you can
I like weird things. You can show it. But before someone shows the weird thing, when the with the ggplot above, you need to actually change those hashtags. So, oh, you moved them. Okay, that's all good. Who wants to show the weird stuff that they have plotted?
Sarah.
Sarah, come, show. You can click on share and then you will start sharing your screen. Oh, this is exciting. Oh, what have you done then? It looks beautiful. Oh, yes. So that error message, you guys are muted, by the way, so I cannot hear you.
So sorry. Can you move up, like, to see the message? The news for
Hey, it doesn't work.
Is this your screen? Yeah, but wait. Yeah.
Yeah. So that error message is because we are using the WGS84 projection. If you change the data to fakeland_HD_UTM, then that error message actually goes away. Yeah, so change the object.
And the HD to UTM.
Yeah.
It's already there.
So I should not.
Right. Perfect.
And then plotting, you can see that the projection system is it's different. It's UTM, but then the error message goes away. It's not an error message. You can see that it says warning message. So this is just literally ggplot saying that if you want to do something on the surface, it might not be calculated correctly. So the plotting is completely fine. You're getting a warning message just telling you that like something just to keep in mind, but otherwise you see it plots, it's all good. So fantastic. I hope everyone got to this stage and you are feeling very proud that you have created a beautiful map. And you can see that those labels can help you also just make sure you can double check things. You can change that to admin 2 actually. So if you go here, fill, actually label admin 2, then all of that changes to the district names, right? We can also change the fill to admin 2, and then all the different colors come up and it becomes a mess. So we can keep it into the fill is admin 1, but the label is admin 2. This is fantastic, isn't it? Because you're able to tell the different regions, you can visualize where the regions are, but you can also get the admin 2 data from this plot. So I hope this has been exciting. you have been able to read things in. And what we will do next, we will start to do the merging. So at the moment, we're just working with that shapefile, right? We just loaded it in and we plotted things that were already attached to it, those attributes of like admin1, admin2 names. So the next exercise is that we're going to be running the following lines. That script to load in the routing data and clean it. It's exactly from like Gloria's workshop when we cleaned it and fixed those errors. So we're going to rerun that one. And then we're going to merge the routing data with left join to the shapefile. And we will calculate prevalence. And then we will plot where the most total tests have been carried out. Whoa, exciting stuff. Before we kick things off, how do we calculate prevalence? What is prevalence? This is from Sangoro's talk, so I'm sure everyone remembers very clearly.
The instructor is here, don't let him down. So, it is already admitted. Do you want to say? I go ahead. Okay, so the prevalence is the total number of people who have been tested positive over the total number of over the population, total number of population in the particular geographical area.
Yes, perfect. I just realized that I think I did positivity rate rather than PR. So this was a really good recap as well, because I don't think that in clean routing data we have population. We did the merging later on, but for now we will just keep it like this. So how does it look like? We're going to go back to the script. We're moving on to step 4, so merging routing data with shapefile. So here's what we need to do. We need to read in the CSV of the routing data. We are going to clean it, then join it to the shapefile. And yes, we will create a new column called positivity ratio, because the population is coming from another data set that we merged it later on, but I wasn't sure that everyone has it. So first of all, I'm sure that this is something everyone is very comfortable doing by now, that you read in the CSV. So the routing data, which is coming from data, then you go to CSVs, and we have the routing data. We actually have the population, so we could all do that, but let's just keep going. We have 20 minutes left, and oh gosh, I've planned so many things. So let's see how we go. So if everyone is ready, let's read things in. We can take a glimpse at our data frame. The routing data frame. We have worked with this before. This snippet is literally from the end of workshop 4, from the self-guided materials. So we read in the routing data frame, selecting these things. We're getting rid of the NAs. We make sure that we're filtering wherever the tested numbers were bigger than the confirmed numbers for both under 5 and over 5. We then replace things. So when admin 1 had a typo, like n.coast, we change it to North Coast. And when some central wasn't capital, then we change it to capital. And otherwise, everything stays the same. We are going to make sure that the months are factors, and we're going to just make sure that it is in like ordered. This is coming from the loop read date package, and I really hope that everyone is familiar with this, because this is from our website. Then year, we had to fix when there was a typo. Otherwise, everything stays the same. We make all these dates. We calculate the two new columns, so two new measurements, test total and confirmed total. So if you run this whole thing, our clean data routing data looks like this. So this is coming from workshop 1. Everything has been prepared really nicely. And we have test total and confirmed total. So in this section so far, you didn't need to change anything. Hopefully everything is set up so you were able to read in the data and run all of this. Is everyone happy so far? Thumbs up.
It's laughing, so I think they are happy.
It's all good?
Yeah, all good.
Okay, fantastic. So this is going to be the hard stuff. So we want to join the shapefile to, join the routing data cleaned to the shapefile. So this is literally what we're doing. We have a polygon, we have a shapefile, we have a CSV, and we want to combine that data. So how do we go about this?
Every time, go ahead.
You guys are muted.
Okay, so we're gonna join the two files by using the left join. So is the name of the vendor. Yeah, left join and then which file should contact?
The one which
Not to write the name of the name of
the name which the one
before left.
before left.
Ah, they are using the, I think she's using that tidy list.
Are we starting with the shapefile or with the CSV? We can see what we need.
Shapefile like this.
We're going to double check what do we need for this function. Oh! Sorry.
Ah,
this is not the right
Mission aborted.
Yes, everything just crashed. I'm gonna open this up. This is not what we need here.
Ah, yeah, someone who is already there. Yeah. Sarah, you need your.
Oh, you can share your screen if anyone has figured it out.
Yeah, she can lead the session. Sarah, you can share your screen.
Okay.
She's sharing.
Or is stop sharing here? Or is that figure? Where is it?
So we have what is that? Alikuwa amesema tunaenda kwenye help.
Help.
Help what?
Help.
Left join.
Left. They don't see. Can you move to the screen?
See you running live.
No, it is moving. I tried that time.
That time it was no.
You see?
Oh,
Hey.
come here. No, it doesn't show.
Okay, but here it is easy.
Yeah, it is visible. I don't know.
Okay, move this pen now. Yeah. Clear the console.
Really?
Yeah, what can you do now? We are not seeing what you are doing.
Maybe someone else to share.
Not sure. There are
I'm share. Hata saa zile
you move.
Finish. It doesn't show.
One more.
My screen doesn't fit there.
All good. I have rerun everything, so I'm all ready, but
Stop sure.
Yeah, you talk to Brian the day before.
has anyone been able to figure it out? How to do the left join? And look, Dr. Usman is in the house.
I'm here.
Usman, I tried so hard to keep you in Australia. Why did you leave? Perth is not the same without you.
They are waiting for me.
Oh, no, thank you for helping. So, how are we doing the left join? Anyone?
So we use the same function. We begin with the shape file.
Yes.
The shape file and then the CSV file. And then you specify the field, the common field you are joining on.
No, I think you start with the CSV.
Yeah, you can
CSV.
The CSV file first. Then you keep the shape file. Alafu.
You said you join by left here.
Alafu unasema by what?
After that,
Unataka hizo na nini?
shape file inside.
So
So you start with the CSV.
yeah. Can you do it here? You join it.
Fake. It is fake.
No, you are joining by which variable? By
Routine we are.
by what? No, by
Don't you
by
Yes. Which thing do you
C.
Do you have it?
Parentheses. Parentheses.
Which chapter?
This
The
right here.
other.
And right anyone can do.
I think it's
This.
the top ones.
Which?
But they are currently
Yeah.
This, not this.
Do it.
which one?
We'll see the results.
Close hapo umeandika unaweka by.
Comma by. Put
Which
them in
is
the
the-
vectors.
You can show
And which is the
the
Administration.
admin?
this one.
Put them by the screen.
Yeah. You see the coordinate here? See?
The coordinates are
Can you share the screen?
displayed.
Can you share the
See like
screen?
that.
Then,
Yeah. If you are done, please share this.
Sure.
yeah. That clip is ready.
So someone is gonna share the screen to show us.
Yes, please feel free to go.
Go to the script. Choose on WA telephone.
Yeah, I think it's done.
Your art is your art. Let's go here.
Yeah, it's done because there are 16 ones.
Are you able to start where we were and then be able to project how you are joining the left and the right?
We are only doing left
that we
joint, so let's stick to left joint
Mhm.
for now. not go to right joint. But yeah, this is what we are
Yes.
at the moment. That's what we are. Yes.
No, this one.
So, oh, there you go. Oh, look, that's exciting.
Bye.
Oh, okay. So if we check again, when you started typing the function left join, it usually pops up, what that function is expecting. And the first thing when you do left join, it actually wants an X and a Y as well. So here because you're using a pipe, you're actually saying that we are merging the cleaned routing data to the shapefile. And we actually want to change that. We want to start with the shapefile, and we want to then join the cleaned routing data. So this is going to be quite important, because if you remember that fake land shapefile, that one has the geometry. That's what makes it into spatial stuff. So if we join it to the shapefile, then it becomes an attribute, what we are joining. If we are joining the other way, maybe it won't join really nicely and everything. So we want to start joining the shapefile.
Yeah, the order of joining.
So I should start with the fake line.
Yeah, I think
I
you did that one, right? Start with this one.
we started with fake line.
With shape.
The shape file.
And then you bring the data.
Yeah.
Yeah.
Fantastic. Let's have a look how it looks like. Oh, look at that. So what can we see? We can see that the geometry is there, and all the information from the routing claim data has been added.
But I think it's still the same.
What?
What are the population information?
The population is not there. Population is a different CSV, which we will need to merge and such. So we're not going to do that because we only have 3 minutes left, actually, guys. I know that with the darting, we usually stay on. So are you guys happy to keep going? Are we happy to keep going for a bit or half an hour? I know, Nema, I don't know if you have to jump on to another meetings.
Is it the right
Yeah,
button?
yeah. I have to drop off, but I will catch up with the recording later on. So that's fine.
Fantastic.
You
Thank
guys
you so
can
much. And I think, Nema, you will be, you will also be quite quick to figure out the rest of the script. Not a lot of things changed later on. So hopefully it will be fun. And maybe in like 1 or 2 weeks, I will share the answers and we can go over if anything comes across.
Yeah, sounds good. Thanks. Before I jump over, I had a question. So for the left joining, I used merged. And I just wanted to maybe hear from you what are the best practices. Like maybe I can also share my screen. So how I
Feel
did
free.
it.
Feel free to share. And actually, like, yeah, merge is just a different function, but very, very similar. I think whichever function you're familiar with and comfortable with, that's completely fine. Yeah. So with this one, the only thing I would add is that try to add admin1 and admin2. So you combine, so you say C and admin1, admin2 in a bracket. And let's see how it works for you with merged.
I think it's small c.
It's small c, and you need another quotation mark after admin1. Yeah.
Does that look good?
Yes, give that a go. Let's see how it works. Okay.
Yeah.
It looks fine.
Yeah. Okay. Yeah, I'd assumed it would have sufficed because it's the lowest level, but I assume for in cases where you have several levels, geographic locations, you have to join by all of them, yeah?
Yeah, so I recommend it both with left join and with merge functions, that the more you can say that are similar between two data frames, the more reliable the merge is. Yeah, but yeah, it works fine. Merge is like, I think like 2 years ago, I was always using merge and now I shifted to left join, but again, the two functions are very, very similar. So it's all good.
Yeah, okay. Thank you. I'll stop sharing now.
All good. Thank you. So was everyone else being able to do the left join? And you can do it like this as well, that if you don't want to use the pipe, you basically just say left join, clean routing data, UTM, and by admin1 and admin2, and by assigning it to a new object. Is everyone happy with this? Have you been able to run it?
The order doesn't matter.
I didn't hear you.
Yeah, you wrote the left join, but you started with the skills file. I'm wondering, the order doesn't matter here.
Yeah, I just wanted to check, and I think it works as well. So I was just checking it. I think it works. I think it's just good practice to start with the shapefile and afterwards do it. I just wanted to double check if it creates errors, and it didn't. So as you saw it on Nema's way of using the merge function as well. In R, there are lots of different ways of doing the same thing, and it's all good to just play around to see what happens. So the next one, to calculate the positivity rate by dividing the tested total with the confirmed total. Would anyone like to have a go at this? How would we do this? Kokoda, I think it's time for you to share your screen, because Dr. Kokoda, Professor Kokoda,
I'm so sorry. I did.
we all want to learn from you. Come on.
I would like to pass it to Sarah. I was doing with Sarah.
You are doing
I couldn't work at the same time I shared my screen, to be honest. I have been working with Sarah, so I can pass it to her. She can share.
But my
Do you get me?
Yes, sir, you can share your screen and Popana is going to explain.
to explain.
Yeah.
No problem. I don't mind.
Coco doesn't share your screen.
Sir, you are.
That we're gonna use the same microphone.
Okay.
And it doesn't show.
What's
This one's so.
and what are these for?
No, you are not there.
We are not here.
What happens in that line? 169.
169. Yes.
Yeah.
So
Use that.
To go with the peer.
what
Use the function mutate here.
Yeah, muted. Right. What's your problem?
You're not supposed to share.
This is your computer.
You think we are doing together.
So now you need to compare it.
Okay.
We want to name the new data PR. So if you
PR.
remember with mutate, let's use capital letters just for later on. It will be useful. If you use PR, yeah, and then equal, how are we calculating this? And again, this isn't prevalence. Apologies for this. This was positivity rate.
Yeah, it is positivity rate. So it's the number of people confounded over the tested. So, but do we have confounded?
Yeah,
we have.
Yeah.
We have. Which one?
Total.
Yeah. Over. Tested. Where is total? Yeah. Test total.
Fantastic. That is it. You can run it.
It's done. Where are we now?
So I think it's actually called Fakeland Routing Data Joined. This is just the CSV when we cleaned it. So down, yeah, that one. Let's have a look if it has added the PR. Yeah, we have calculated it. Fantastic.
Yeah,
It's
it is here.
a new column, yeah.
Okay.
Yeah.
Okay, now we have it.
But Popana, you have to change the comment, the script.
The comments.
Yeah, go to the script.
Go to the date.
And add it here.
Yeah. In line 162.
162.
162. That one? Yeah, you can go right. 162. Yeah.
162.
Yeah. Yeah. What is the message in the right?
What is in the right?
Total.
Tested.
Yeah, you have to put it here. It's constant divided by test. Yeah.
Tested divided by the
No, wait. So that if you scroll up,
like this.
Yeah, you have to connect.
Vice versa.
Yeah.
we don't need. Wait. We don't need to correct it. If you scroll up, that's the description of the cleaning step. So if you scroll up a few more lines, you'll see, there you go. So test total and conform total at line 156 and 157. Can you see? 157? So that's where like that explanation is related to the script above. So it basically just says that we are doing the admin naming and we are calculating the test total and confirm total. So we don't need to change anything over there. I think you guys heard that something needs to be changed, I think. But that's all good. So what we have done, and it's up to you if you want to keep sharing your screen or no. Okay, I will start sharing my screen. So what we have done the positivity rate. If we try to keep the lines consistent, so if there was an extra enter, maybe get rid of it. Just it will be easy if we refer to lines later on. So next one, we have calculated the positivity rate as well, but we want to use ggplot. So we want to plot the actual joint data. How do we go about it? What do we change here?
This one.
Yeah,
Yeah. Say
the joined one, the specular routine join.
Like this?
Yeah.
We are selecting that we are going to be using this object. And just as a reminder, if we check the head of that one, yes, it is a spatial polygon, and this is the data that we have. We want to fill it with something. What should we fill it with? This should be a metric. And we want to plot the total tested, maybe? What do we think?
yeah. The new column just
We can do PR as well. So after this, we run it. It looks like this. But we can get rid of this. So I'm going to switch that off with Ctrl-Shift-C, just for better visualization. And this one is positivity rate in the fake land. So if you can see, I've changed the title and I have turned off the labels just for clarity. And what we can see here, and we want to change the legend name as well. So there you go, positivity rate. We can see that in some areas it's higher than in other admins. We can change the fill to total, to test total. Then we say total test and change the title. Total tests. And now it looks like this. So is everyone happy with this? That you can change this to PR, then you have to change the title and the legend name. If we switch, so Here was with PR. I said positivity rate, I updated it. When I switched to total test total, I have updated the legend here and also here, just to make sure that like we are printing out the correct metrics. And what we can tell by these two plots, for example, that the most tests were kind of like carried out here compared to here where few tests were done. But when it comes to positivity rate, it was higher here, for example, in these two regions compared to, for example, this region. And then if you want to, you can put on again the labels. So I switched this one on. So I removed the hashtag. And then it will print out your region names as well. So this is how we can play around with the plotting. Everyone happy with this? Like to get the structure of how to use ggplot? All good. Fantastic. So what we, again, as a reminder, we literally just did this, right? We had the shapefile, the Fakeland one, it didn't have data. Then we had the CSV with the routing data cleaned. We joined them and then we plotted it. So this is so cool. Now you know how you can make a map. But when I was making up this exercise, I wanted to also say that so far we have been very excited about plotting things. And it has been beautiful. But the thing is, just because it's pretty, it doesn't mean that we are actually plotting the correct things. Because what we have to remember is that all the data that we were plotting, we have multiple health facilities and we have multiple months of data. We didn't do any aggregation of the data beforehand, right? Everything is still here. We still have these separate health facilities. We still have the different months. So when you tell ggplot to plot it, per different admins and such, it is going to take the first row of your data frame. So you're actually losing all this information because we didn't actually prepare the data correctly. We do need to calculate the sums and averages across health facilities and months before we're plotting things. So if we facet wrap that shapefile, because the month is still there, we still have that information, then you will see that all that information we actually ignored previously. And again, oh, sorry, I need to actually add facet wrap per month. And then we add enter. Let's see, type it down. We'll have all of this. So all of this data actually was lost before we did it. We only plotted the first row of like one region, of one health facility, of 1 month. So this is something that with plotting and everything, you really have to first make sure that you have indeed prepared the data correctly. So again, in here, we just had to add facet wrap per month. And what plotting is actually useful, and I'm sorry that Powell isn't here, is that what we can see, there are holes in our data. And, by just looking at the CSV here, like we can check things and everything, but we can overlook things very, very easily. If you plot things, the errors will jump at you a lot more. So just for time as well, the next one is we are grouping things per health facility, so HF. We're keeping the geometry. This is just so we keep this in. and we are counting how many health facilities per region we will have. To plot this, we just use HF summary. So, what did I forget? HF, group, geometry, routine. Something is missing. Let me just double check. Is 111. Oh, what am I doing? I'm going to cheat now because we are grouping health facilities for each admin too. Sorry, I wasn't reading my own comments. Let's have a look. This is the one. Sorry, guys. Yeah. So what you can see here, what I was trying to do was rushing across. So we wanted to summarize the number of health facilities for each admin too. So first, when we select the joint data, again, we're working with a shape file. We're grouping them by admin two. And when we're grouping them by admin two, we can calculate how many health facilities, and we're keeping the geometry in that shape file. And we're keeping it as a shape file, so like an SF object. This is just something that like you change a few things. We're not going to do anything with the data. This is just, again, an illustration that all of this information as well was getting lost beforehand. So we can actually remove this from our environment. And what we actually need to do if we move to step 6 is that here we need to create a monthly summary with aggregated for each region and month. So over here, we will do admin 2. And do we need month as well?
Hello, Jennifer.
Yes. Is it too fast?
So fast. Yeah, you're moving fast. You're moving so fast.
Now,
Okay.
can you slow a bit?
Yeah.
Okay. So over here at 5.2, what we were doing, we were calculating the number of health facilities per region. So over here, the original script, this one had hashtags. So you just add admin 2 because we want to calculate it for each admin 2. The summary function, we are creating a new column that's going to be called number of health facilities. And we are calculating the number of distinct health facilities here. Yeah.
But you can see now. Maybe this way.
Yeah.
So what we will get here, we'll get the admin 2s. We'll have the number of health facilities per the admin 2s. And we will keep the geometry from just the first layer of geometry per admin 2 because it doesn't change. This is something it's just because it's a spatial object. On group, you can remove this one, but I think this is regarding the shapefile again, because we're changing things and geometry. If it would be a CSV, you can kind of skip that one, but we are keeping this as an SF object, which is spatial. So if I say class, you can see that the HF summary, it's an SF. It's also like table and data frame. So it has a lot of different information. Is this okay?
Yes.
Okay. So to plot this, I think the only thing that was missing from here was that we need to change that we're going to be using this object, the HF summary. The fill is going to be the number of health facilities. If you run that one, then you get this plot.
Which one?
It's the one with bubbles.
I hope you see the plot.
But I was hiding the plots.
Could everyone get this plot? It's beautiful, hopefully.
Yeah, exactly. Beautiful. They liked it.
Oh, fantastic. Look at this. It's so cool, isn't it? I remember the first time when I figured all this out and I was like, this is so pretty. And you can play with different colors if you want to try out. I'm literally just changing these options, and these are different palettes as well in Scale Viridis. But if we have this one, the remove function is something that we can get rid of things from our environment, because you can see that we already have quite a few things that we don't need. Like I had that PF incident stuff that I think we don't need. So you can see that I've cleaned that up. So that's also just good practice. When you know that you don't need objects, because you can see that our memory is filling up. So whatever you don't need, you can use the remove function. Are we happy to move on?
Yes.
Fantastic. So in the next one, we will aggregate it per admin 2 and month across facilities. So this group by stuff, whatever you don't include over there, it's going to summarize across. I hope that makes sense. So basically, if I were to leave the month off here, let's just run this just with admin 2. Then I'm just using head. Then we can see that it's admin 2 testconf PR. But what if I add here admin 2 and month, and I run it, and then I use head, you can see that month appears here as well. And what we actually want to get to here is this stuff that we will get to the monthly that has been actually aggregated across health facilities correctly. So again, over here, the group by, we want to group it by admin 2 and month, which means that this is summing up across all these health facilities that we have in our data. If you check it, you can see again admin 1, and it has monthly data that has total, confirm, total MPR, because these are the things that we kept in our data frame and calculated things and such. Is everyone happy with this bit? Yeah. So we have calculated across health facilities. To then plot this, we want to fill it with PR and pass it by month. So PR and month. And what is the important thing about this is that hopefully you can see it still has holes and everything because our data has holes itself. But the data we're visualizing is now actually correct, because beforehand, when we created our very, very first map, like this, and we created PR, it didn't count, we didn't summarize across health facilities, we didn't summarize across months and such. So I hope what you gain from this exercise as well, that yes, we know how to merge a CSV with a shapefile. That's fantastic. That remains a shapefile, and within that shapefile, we can use all these different functions and calculations just as we would do with a CSV. But some things that are a bit strange is like you need to keep the geometry and you need to use this function that we are keeping it as an SF object. Are we happy until here? Because in the next one, oh, good. So again, with these visualizations, we want to find the holes, and then we can see if our data is actually missing or what's happening in there. But it would be so nice if this could be interactive, if we could click on things and things would pop up. So in the next session, this is literally just very, very quickly, I will just demo this, just so you are aware what's out there. And I would really like this R package called TMap, which makes plotting quite nice and beautiful. And it works like ggplot, kind of, that you're layering things on, but you can layer on, like you can specify with tm_shape, that's the data basically. And then you can say that this is a polygon. And then you say that, okay, from the polygon, we want admin 1 or admin 2 to be mapped. Then you can actually add another shape, another data, and then a raster and specify like what the raster is inside. So we don't have to go into too much detail, just I wanted to prepare you what you will see in the script. And we can set the TMap mode to view, which is not interactive. But if you run TMap mode plot, then it becomes interactive. Now we are working with a fake scenario. So all of it is, it's a fake land. It's not an actual country. So we are literally using the routine data join. So again, this shapefile. I'm specifying polygons. I'm saying that the color within it, it's going to be PR. Alpha means that it's a little bit transparent, 0.3. ID, it's going to be for each of the polygons. Pop-up variables, this is what I'm going to click on. These are the variables that will pop up. The palette, I have reverse Viridis. So if you put literally a minus sign in front of a palette, it just flips. So basically, if it's black to red, then you put a minus in front of it, it would be red to black. The style is continuous because our PR, the positivity rate is continuous. Then layout, I'm going to have a title and a legend outside. So I'm just going to run this one. You can see a lot of things have changed with TMap, so that's why it's kind of just giving us these updates. And you can see that we are going into viewer, so not plots, but viewer. And this has become, interactive on the map. Again, this is a fake country, so it's not overlaying a normal country. It's just whatever CRS it was in, we plotted it on top of like a normal global map from like leaflet.
Ghana. The fake country is closer to Ghana.
I know. I'm so sorry. It should have been. I should have moved the coordinates in middle of the ocean. I'm not trying to suggest that we need this country, or I'm not trying to make a political statement with this fake country over here. But hopefully you can see that again. This can be super useful when you are exploring your data, and you can change. You can change the base map as well to visualize different things. And then you can plot things as well later on. And then next one, again, we are just going through this so you know that this is out there. We can make GIFs with our plots. So exciting. This is something I love to do. And this is something that like, it can be useful or it can be distracting. If you want to make a point of like, look at these holes are changing across the different months, this is a great visualization. And this is coming from GG Animate R package. What we will do, we will plot a basic map. We just need to assign it to an object. And after that, we need to kind of define the transition states. So how many seconds we're going to spend, you know, on each map. And then we have to render it. So we use the function animate. So the way it will look like, that we have the fake land, we have the positivity rate or ratio. We are saying that this is a spatial one. Again, where it is, we are going to print out that this is fake land per month. And per here, which is a different parentheses. I don't know what the word is in English. This is how you define the closest state. So your state will be like what you animate over. And you just need to say that like, this is what you need to print out with, because GG Animate will print out these plots and we need the actual text to be updated. The fill and theme minimum, and we are assigning it to P object. So if I run this one and I call P, then a plot will appear, if my computer is okay. And you can see that over here it says closest state. When we then add this transition state, we specify the states, which is going to be the variable to animate over, so month. We will say that the transition length is going to be 2, and the state length will be 3. You can play with this, you know, if you want to make more of a point, we can increase this to 5 seconds. And we will assign it to another object, which is called pAnimate. And after that, with the pAnimate, we are going to actually animate it. This is like if you ever exported any videos from your phone as well, you would usually have this frame rate and size and such. We assign it to anim object. And if you call that object itself, it's going to pop up here. It just takes a bit of time because this is rendering it. So this is actually, you can see here, we have a progress bar and ETA, how many more seconds are left. And it's done. If we call it, my computer is so slow today. Ah, look at that. This is, we created a GIF and it's looping over the month. And to actually save it, you just use the function anim save and the animation is anim and you specify the name.
Maybe it's your first time.
And you can see that it has appeared in a folder. Is everyone happy running that bit of code? Again, this isn't something that...
Start there?
Yeah, really does this one. It says in animation report.
There is some.
Oh yeah. This works. This one as well.
Has it
I
worked?
think some of them have some message from view.
You're welcome to share it. Share the screen so I can see the error message.
You can share your screen, please.
You can start sharing, and I will stop, but you can always override me.
This one.
Did you trust
So you need to install GG Animate. So if you use the function install.packages, I can put it in the chat as well. If you have installed it, make sure that you load the library by saying library GG animate. Those error messages basically said that they cannot find these functions, which means that either your package is missing, so it hasn't been installed, or you just haven't called it.
It's okay.
Oh.
You have to learn from this one. Yeah. It's busy, it's running, so you have to
Rendering, no.
It is still running.
Sorry, that was not an issue, but when we create this challenge, I call it the library.
View. No, you just run.
So the list.
So it's this one.
If there are anyone
And then you
who are done,
you have to.
who are able to do it,
And why is it not showing?
Any email you web that was not
How are you guys doing? With TMAP, if you say TMAP mode view, then it has gone back to plotting. If you want to go back to interactivity, then you say TMAP mode and then view. So you can switch in between those two. But again, these two packages, I just wanted to show something cool that you are able to create all these really fancy things as well. Has it worked? Have you guys been able to run it?
I've tried, but
I'm really not following.
Yeah.
I've personally run it, but the plot is not sure.
Oh.
I like it. Just like, yes.
Oh.
I think you should share. Yes, we all have that error. Not message.
Yeah, the message is like
You also have that. You also have that.
Can you share your screen, please?
Please feel free to share your screen. Yeah, for the error messages.
we're gonna share what we are getting. Oh, when we try to run this running library
Directory.
here.
We want.
So
Can you see yeah, from here when we run this, we get this message. What is the message?
I'll render.
The message.
Hey. What's wrong with it? We can see it from our end, but
Let me just have a look.
no, it should take it down. But here,
Yes, it is.
that's wrong.
Okay, this one.
Yeah, just
Wait,
scroll down.
oh, yeah, this one. Oh,
So that's a different message.
This
Yeah.
This one.
warning message. Yes.
Go to view, yeah, start, go to view.
How to the file here. Okay.
Listen.
There is no.
If you guys want to see what I have found, just quickly as I look this up, I'll just start sharing.
Did you also
It's not hard. It advise you to restart app. To say restart app session.
Restarting.
You do that after explain the generate.
Did you know she didn't restart it? You know, restart it.
You didn't start.
No, when I installed the package, it restarted.
That's
Yeah.
it.
And now go to.
So
Is this coming up for everyone, by the way?
yeah.
Yeah, from here,
Oh,
Here.
that's so strange because I have never got that error message. I can show if you'd like, just like how I try to troubleshoot this. And let me just bring this up. So I will start sharing my screen if that is okay. And what we can try. Yeah, so I literally just entered the error message into Google, and you can see this is again Stack Overflow, where lots of people share errors that they come across, and you can see has it started saying that it started rendering when you first ran it, or did you get the error message right away?
It started rendering.
Okay, so double check in the destination directory if something is there, just to see if it was printing out anything.
And now do you know this destination?
Probably it didn't. I don't think it should, but in some messages as well, they said that they have to go and delete whatever it actually created in the destination directory, but I don't think that was the thing. But this GIF ski renderer seems to be what other people have also recommended. It's coming from another package again. What we can try, but beforehand again, this is Posit community. So our studio is actually called Posit. It was a whole rebranding thing. And again, you can see that people share, like it could be, you know, permissions to your writing thing as well, permissions. And you can read what people have come up with, which is really cool, actually. And there's another one as well where people are talking about this one. So I would recommend installing this GIF package. And what we will do, we'll try this, what they suggest over here. So I will write this up.
View ni kwa zile nani ambazo zina move, picha ambazo zina move.
Kwa hiyo inabidi uangalie kwa
Kwa mfano ile interactivity ubonyeza hivi inatoa jina, inakuwa displayed kwenye view, sio
hata tu
if you want to hear it,
I will put this in the chat as well. To install, then load the library, and then try to animate it and specify that that's the renderer that we want to use.
Did you try the myself? No, you need to specify.
Where? What should I specify?
But the chat, she just sent that. Go to the last thing she shared. Then you need to specify animate. Then this remember. This from here. Yes. In the animating function.
Yeah, animate.
There is one more parameter specified from the library. Yes. The missing of the spikes. That's a screen G5.
Where is that called?
Did you get this message?
oh, coconut. Oh, it's probably. Maybe before you can ask for the other guys online if they.
So
They have.
everyone else has left. Yeah, they had to go at on time today. So we don't have anyone else.
Only you.
Yeah.
People join. This number of participants you see here, this one.
Only.
Yeah. No,
Yeah.
they left.
Yeah. Maybe they will figure out this after.
Yeah, Sarah will figure out.
If you'd like, I will send this over to you guys as well to try. I think hopefully this will work. Again, like I put it in the chat, so to specify which renderer to use for the animation. But again, this was supposed to be something that's quite nice and fun. I'm sorry that you guys got error messages. Does it work? Has anyone tried out that GIF ski renderer thing? Has anyone run this one?
Not yet, they are copying the scripts.
Just a minute.
Oh, good.
This slide. You see? Animate, go to the chat.
You need to add it separate, not inside.
Where?
It's
It's separate.
Okay, you already done it. I think it should be at the top.
Why? You need to tell them.
For are you sure? For
I think it's easy.
No problem. It's just
It is the same area.
so that it's
the same.
Oh, you are.
Yeah. That's what.
actually gives.
Hey, finally, someone.
Yeah. It works.
Someone.
Yeah.
Did it work?
Yeah, it's what?
Oh, is it with the GIF ski or the normal one?
With the, yeah, with the G.
Ah, fantastic.
Finally.
Thanks for giving.
Thank you so much. If you guys want to look into it, there are whole different renderers that we can try as well. Again, this is quite like advanced stuff. So I'm sorry that like it threw out errors. There are also like different renderers that you can use for all of this. So that would have been my next step. But hopefully the GIF stuff works.
Which one?
It's working also.
Yeah.
Yeah, it's working.
Fantastic! I have to say, so that was going to be my first thing, that after all of this, we get to have a break. So
All right. Yeah.
Not coffee break, yeah?
Yeah. It one.
I hope that, you know, all of this has been really fun. I think I have prepared enough material for maybe another couple of workshops, to be honest, because this is, after this, we would have started working with rasters, the other files, but we can have a think for next workshop, because that's going to be like the assignment intros. Maybe we can finish up the rasters then. And then it will be up to people as well how much they want to do, because it's going to be, I wanted you guys to get to this stage using the Malaria Atlas R package, reading in points, counting from points to polygons, then reading in rasters and looking at different covariates as well. And all of this is actually in your script. And what you can see here, I think it's like over here, it's literally how to save a shapefile. I think most of this, I have given you guys the answers, so you don't need to change anything. Over here, there's one more thing And I'm giving you the answer up here, so you can see that like it's geom raster that you have to add over there. So for all of this is quite a lot. So whoever would like to jump into rasters, you are welcome to this week. But what I will do, I think, at the next workshop is to go through all the raster stuff. Because if we can get this whole thing in our heads, that we have the shape files and we have the rasters, and how we can play with these two kinds of different data files, I think it will be really, really useful later on. And down here, there's a whole section about the Malaria Atlas R package. So how you can access all of the data that actually here at MAP we create. And you can get the data from our databases through this R package. And this is like, this R package was written by Mauricio, so he's literally just sitting across me. And you can get the shapefile, you can get the points, then you can get the rasters and just bring all of this knowledge together. But I'm not going to go too much into it. For now, with the GIF stuff, or with the Git stuff, please commit your changes. So save your script that this was at the end of shapefiles or something, maybe the commit message, and all your outputs. And then at the next workshop, we are going to go into rasters as much as possible. And then all the assignments as well. Does that sound okay? What do you guys think?
Yes, it sounds okay.
Okay, fantastic. Thank you so much. And I hope that this was exciting, that now all of you can create, get a shapefile, merge it with a CSV. And if you have your own data as well, I really hope that this is something that you will be able to create, and you will be very happy with your pretty maps. And then we'll continue next week. I'm going to stop sharing. Oh, I did want to do just one thing, that afterwards what to do. So we have the self-guided material as well on the website. So start going through those, but again, up until rasters, because I think we need to have the rasters introduction properly. And there's a whole free global conference coming up between the 9th till the 12th of April, completely free. It's all going to be about like our Shiny apps. It might be, it's quite a steep jump from all the stuff we have been doing, but I think this is an amazing opportunity as well, that you can attend workshops, you can network with people, so you can see workshops, dashboard design, reactivity. Then there are lots and lots of amazing talks as well. It could be also kind of like just basically like how to create some things that are interactive and are correct, and like storytelling and everything. And again, it's very easy to register and it's all for free. It's fantastic. So I will be there. It's going to be like all night for me, but I really love this stuff. So I will share this in like an email as well afterwards. I will send out an email tomorrow then, just to recap what we have done and what we will do next. Any questions at the moment? All good. Fantastic. Was this fun? Was it good?
Yeah, it was really nice.
Oh, I'm so glad. Yeah, there's so much, and I think it's really cool when you get into building pretty maps, and especially if you have your own data, it gets so exciting. But again, You guys have done amazingly, like considering, you know, like we're still getting used to R and we're wrangling things and we're working with a completely different data. So again, like just be really, really proud of yourselves as well. I will see you next week. And I will email everyone then tomorrow because it's getting late over here. But have fun and enjoy the rest of the week and see you all next week then.
Okay, thank you.
Bye.
Thank you so much. Bye. Have fun.
Thank you.